The trigonometric identities. So we will get started with the reciprocal identities. What that means is that they are the 1 over one of the other sine, cosine, tangent, cosecant, secant, or cotangent. So if you do 1 over cosecant, you get a sine. And if you do 1 over sine, you get cosecant. Similarly, if you do 1 over secant, you get cosine. If you do 1 over cosine, you get secant. If you do 1 over cotangent, you get tangent. And if you do 1 over tangent, you get cotangent. So these are the reciprocal trigonometric identities. Let's move on. So next we have the Pythagorean identities. You can think of them as the triangle. You square the two sides to get the square of the hypotenuse. So in this case, you're going to not square the two sides, but you're going to square the trigonometric functions themselves. So you're going to square the sine and you're going to square the cosine. And when you add them, you're going to get a 1. So you can think of it as kind of combining the ratios and using the Pythagorean theorem to get these identities. So sine squared plus cosine squared is going to be 1. And then 1 plus tangent squared is going to be secant squared. And 1 plus cotangent squared is going to be cosecant squared for the Pythagorean identities. If you forget these ones, you can always derive them using the Pythagorean theorem and the identities, the ratios themselves. But if you're planning to take some sort of a test or need to know them repeatedly, then it's good to also just remember them. Now, the next one we have here are the different ratios in the trigonometric identities. So again, you can figure these out simply by doing ratios or canceling them as well. But so for example, I'll give you an example. Sine is opposite over hypotenuse, right? So if you took cosine, which is adjacent over hypotenuse, and you took cotangent, which is adjacent upon hypotenuse, and then adjacent upon opposite, right? So the adjacents, the outers over inner, the adjacents will cancel, and you will get the opposite over hypotenuse. So cosine of theta over cotangent of theta is sine of theta. So you can figure these ratios out that way, but we'll just go through them. Cosine theta over cotangent theta is sine theta. Tangent theta over secant theta is also sine theta. Sine theta over tangent theta or cotangent theta over cosecant theta is cosine theta. Sine theta over cosine theta, secant theta over cosecant theta are both tan theta. So you get the idea. I don't particularly like to remember the ratios like this. I like to just take the actual adjacent, opposite, and hypotenuse ratios and cancel them out and see which one it's going to be. Because it's very easy to confuse them and then get them wrong and then have your calculation be wrong. But if you simply take the actual sides and the ratios, you're not going to mess them up and not be wrong in your actual calculations. So next we have opposite angle identities. So the idea here basically is that if you take for sine and tangent, the negative sign comes out, and for cosine it just disappears. So if you take cosine of negative theta, it'll just be cosine of theta. And the other one it disappears for is secant, because secant is really the reciprocal of cosine, so it's 1 over cosine. So for sine, tangent, cotangent, and cosecant, the negative sign comes out. So So that's the easiest way to remember the opposite angle identities. By opposite, we just mean the negative side of theta. Okay, so next we have the complementary angle case. So that's where you take, you subtract theta from 90 degrees or from pi over 2 if you're doing it in radians. So here, sine of pi over 2 minus theta is cosine of theta, and cosine of pi over 2 minus theta is sine of theta. Similarly, cotangent and tangent are opposites, and cosecant and secant are opposites when it comes to complementary angles. All right, next we have the supplementary angles. So instead of subtracting from pi over 2, we are this time going to subtract from pi, or 180 degrees. And so when you subtract from pi, you will get for sine of pi minus theta, just sine of theta. For cosine pi minus theta, negative cosine of theta. And for tangent pi minus theta, also you will get the negative tangent of theta. All right. I think we could have also done here the cosecant, secant, and cotangent, but I'll let you work those out as an exercise. All right, so here next we have the sum and difference formulas. So in a way, when we were doing pi over 2 minus theta, that can also be derived from a sum and difference formula, because it's just the sum or the difference between pi over 2 or pi in the supplementary case. So if you're doing the sum or difference, the sign stays the same in case of sine and flips in the case of cosine. And with sine, you do sine cosine plus cosine sine. And with cosine, you do cosine cosine minus sine sine. So essentially with sines, you do sine cosine cosine sine. So sines are on the outside and cosines in the middle. And with cosines, it's cosines first and then both the sines. And then tangent is a little bit different. Now you can also figure tangent out using the first two of sine and cosine and canceling terms and things. But it's also useful to just know it. So again, that sine stays the same in the numerator, but in the denominator it flips. And then you have tan of A and tan of B in both cases, but in the denominator you subtract it from 1. So that's the sum and difference formulas. So basically what we're saying is we want to take the sine of the sum of two angles, or we want to take the sine of the difference of two angles. That's when you want to use the sum and difference formulas. Next we have the double angle formulas. So again, you can derive all of the double angle formulas using the sum and difference formulas, because all you have to do is place the same angle twice. So for example, if you wanted to know the sine of 30 degrees, so let's say A was 30 degrees and you wanted to know the sine of 60 degrees, so that's sine of 2A, you can use the sum formula and say it's sine of 30 plus 30. And so then you would get sine of 30 cosine of 30 plus cosine of 30 sine of 30. Remember we said it's the same sign for the sine, and it goes sine cosine cosine sine. And for the cosine, it goes cosine cosine, the sine flips, and then sine sine in the last slides, right? So here when we have sine of 2a, let's think about how we can use the sum of sine of a plus a to derive 2 sine of a cosine a here. So the first term in sine of a plus a would be sine of a cosine of a, right? And the second term would be plus cosine of a sine of a. Now you can multiply, you can multiply them in the other order, so you can get 2 sine of a cosine of a. And so you can see how sine of 2a can easily be derived using the previous identities that we learned. And the same goes for the rest of these. So if you can remember the ones on the previous slide, for the sum and difference formulas for sine, cosine, and tangent, then even if you don't remember the sine, cosine, or tangent of 2a, you can very easily come up with them simply by using a as both your angles. So, but just to go over them, sine of 2a is 2 sine of a cosine of a, cosine of 2a is cosine squared of a minus sine squared of a. Cosine of 2a can also be written as 2 cosine squared of a minus 1. So we use the Pythagorean identity in here along with the double angle formula. And then you can also do the Pythagorean identity the other way, so you can also write cosine of 2a as 1 minus 2 sine squared of a. And then tangent of 2a you can derive using the sum and difference of tangent formula as well. Alright, so half angle identities, same kind of thing. This time we are, instead of adding up the angles, we are dividing by 2. So if you're dividing the angle by 2, then you can work it out as the sum formula should hold up for the half of the angle, and that should give you the full angle. So you can derive that way, but you can also just remember the half angle identities because they're a little bit trickier in the derivation than the double angle identities. So if you're wanting to remember them, then sine of x over 2 is the square root of 1 minus cosine x over 2. The cosine of x over 2 is 1 plus cosine of x over 2. And tangent of x over 2 is the square root of 1 minus cosine of x over 1 plus cosine of x. So here you can see the tangent of x over 2 is basically sine of x over 2 divided by the cosine of x over 2. Okay, and then if you square both sides, then you can also get the other version of the same, where you have sine squared of x. So there's a little bit more manipulation here that you would want to do to get from the first one to the second one, but given all the identities you already know, you can actually do that pretty easily. Alright, so next we will go over to the product sum trig identities. So before, what we did was we said like cosine of a double angle or cosine of a plus b within the parentheses. But now we're going to do cosine of a plus the cosine of b. And so these are kind of the, on the left hand side here you have sums or differences between the cosines or the sines. And on the right side you have a product that comes up when you solve for these. So these identities are also pretty useful to know. So here we can see when you're adding up cosines, you basically get the product of cosines. when you're subtracting cosines, you get the product of sines. Similarly, when you're adding up sines, you get the product of sine and cosine. And when you're subtracting sines, you also get a product of cosine and sine. But the terms, the first term will be a plus b over 2, and the second term will be a minus b over 2 when you're doing these identities. And the only time you're going to put a minus 2 in front instead of a positive 2 in front is when you're subtracting the cosines. So that's a little bit more to remember, but you can do it if you would like to. And these are actually pretty useful identities to know. All right, last but not least, so we just did the sums of sines and the difference of sines, and the sums of cosines and the difference of cosines. Now we'll do the products. So here we have the product of cosines, the product of sines, the product of sine and cosine, and the product of cosine and sine. So these are basically the reverse of the ones we did on the last slide, in a way, because this time on the right side we get sums of cosine of a plus b plus cosine of a minus b. For sine we get cosine of a minus b minus cosine of a plus b. So if you remember on the last slide, when we took, for example, in this case the second one, cosine of a minus b minus cosine of a plus b, it's two cosines and they're being subtracted, and they give a multiplication of the two sines, right? So here you can see when we took the difference of cosines, we also still had the multiplication of sines. So the only thing that's really changing is what's in the parentheses, because we're doing it as a or b. So it's basically substitution that you can use to go from the product sum, from the sums to the products versus the products to the sums in this case. So simply by doing a little bit of substitution, these identities are actually the same between the products and the sums. So that's it for the various trigonometric identities. I hope you enjoyed this video, and I think the best way to do this is to practice them. And if you practice them enough, then they will become second nature, and you will be ready to move on to higher math courses where whenever some sort of a trigonometric function or something comes up, you are able to just solve it without really having to think too much. Alright guys, I will see you in another video.